Hi, I'm Irem. I'm currently a freshman at Bilkent University Industrial Engineering Department, and this is my Physics 101 project. And the title of my project is Relations between Maximum Height, Range, and Velocity in a Projectile Motion. To examine this topic, our experiment needs equipment of an air table and its accessories to absorbing the motion, reducing friction, and also measuring the time by its dots, which are created according to the timer, a ruler to measure the distances, a scientific calculator to calculate the equations, a spring to launch the pucks on air table, and a protractor to measure the angles between flying root and surface, and a block to create the slope on air table to achieve a projectile motion. First, we prepare the air table, put in a block underneath to create a slope, and place in our spring with a certain angle. Then we plug our air table. After preparing the air table, then we do our experiments. In each one, we tense the spring differently in order to change plug's velocity. To calculations, I used the ruler to measure the range, maximum height, and also distances between dots, which were created according to spark timer with 50 milliseconds apart. With these information and the distances between dots, I calculated the velocity. Then I measured the angle θ0, the angle between the surface and the flying root, with protractor, which is 60 degrees. The block created a slope of approximately 5 degrees, which will affect the measured gravitational constant. In our experiment, we calculated the g measured as 9.81 multiplied with sine over slope, which equals to approximately 0.98. Mathematically, our ratios must be height over velocity squared is sine squared θ0 over 2g measured, which is 0.38,416. Height over range is tan θ0 over 4, which is 0.4330, and range over velocity square is sine 2 θ0 over g measured, which is 0.8872. Let me do the calculations on experienced measurements. As a result of this experiment, we see that expected results are applicable with small rates of errors. Thank you.